I read you won the first prize in a ploughing competition. Is that right?
Yeah, one of my hobbies is match ploughing, competition ploughing. Yeah, so and the British, they have a British championship every year. So people qualify from all over the country to go to it. There's usually about 250 people ploughing over 2 days, about 15 different classes. And I've done about 10 of these. So I've been doing it, competing at the national championship for 10 years. And I won my class this year, so I am the British champion.
Whoa, congratulations. I don't know how many are already listening, but we've got a British champion here, right? An actual athlete.
Very agricultural, this is. So I compete, I use a 1961 little Massey Ferguson tractor.
Oh, wow. And I have to ask, I mean, looking, this is a scientific seminar, right? So how is that assessed? How is a ploughing competition? What is the metric to determine that somebody is better than somebody else?
I actually did a presentation to the Northern Ireland branch of Ag Engineers on ploughing because they wanted me to do it. Now, I wasn't keen on doing it because it's not high tech, it's not cutting edge, and they said no, we really want a talk on it. And when I sat down and thought I better write a presentation then. And of course, when you sit down and try and put things together on slides, you have to really think about how you're going to present this. Yeah. And the interesting bit with the scoring, just about all the scoring is totally applicable to modern day cultivations, in that the reason straightness is a key thing. And the reason you go straight is because when they used to plough with horses, it's harder for a horse to pull the plough around the bend than straight. So it's less draft. So there's your first technical thing. It's easier to pull something straight than bent. So of course, as with any competition, you really heighten that, and straightness becomes an absolute prerequisite. Then you'll have things called seed bed and firmness, because you want to create a good seed bed to travel across and cultivate and sow seed. You want to bury the weeds, because back years ago, there was no sprays. So you needed to seal the weeds under the turned soil to stop them growing through. And all these things are all judged. So there's about 10 different aspects, and they're all totally applicable to today.
It's like figure skating.
Yeah, and it's the same. And I suppose it really started years ago. You know, the person who did the ploughing on these estates many years ago was higher paid. It was a skill. It was a country skill. So he was higher paid, and the ploughing competition started from landowners bragging about their chap's better than his chap. And what they ended up doing was having competitions. Say, well, I'll put my guy against your guy and we'll see who's the best. And that's how it all started. You know, people bragging about, people's abilities. And there were some really sizable prizes on offer back then. So you get like a week's wages for first prize for a farm labourer. So you can imagine back then it was quite a big deal. So yeah.
So we should be really grateful that you're here, because you've already made your week's wages yesterday. Then
So yeah, I've had a lot of it's been quite funny really with the few meetings I've been in just lately. People have been announcing it, saying congratulations.
So for those who joined a bit late, let's begin. So we've got Charlie Nicklin here, and besides what you see on the screen about his bio, which is all very impressive because he's been working in agricultural domains for quite a while. He's relatively recently joined as the CEO of IAgrE, but lots of experience before with JCB and so on. And so I think the biggest achievement that I've told him already, and I found on Twitter, was that he is actually the British champion in a whatever niche class of ploughing. And I mean, you're definitely the first British champion we've got here. So very, very welcome to you. I'm going to have a few things to mention before we kick off properly. Also to fill some more time for people to finish brewing their teas and coffees and whatnot. So this is the launch of the new season of the AgriFoRwArdS CDT seminar series. We have that every month. So I can already tell those listeners right now that the next one will be on Friday the 19th. And it's a bit of a surprise still. We haven't got the speaker finally confirmed. So watch the space on the website, on the events page there that when we will actually announce who will be our surprise guest in the next month. We have also just opened the recruitment for the next round in the CDT. So in particular, if you know anyone who's interested in the overlap of agri-food and robotics and really wants to make a difference in the world, point them towards our website. If you just search AgriFoRwArdS CDT, you will surely find it. And just for the benefit of everybody else, we are recording this session and we're also live streaming that on YouTube, and we'll make it available on YouTube afterwards, because we really don't want to lose all the insights that Charlie is going to share with us relatively soon. That was my initial starting page. How are we going to operate today? So try to confirm with me that he's got about 30 minutes or so of content to share with us. And after that, we open the floor to general questions, but also we've got a panel of one academic and 2 students who will hopefully have some interesting questions to ask and have start off our discussions. But we really invite the audience in to participate as well. For those on YouTube, just pop any comments and any questions you've got in the chat on YouTube on the comment section there, and we will relay them to Charlie. Those people engaged on Zoom directly, you can pop those into the Q&A section, and we'll pick them up from there. I think that's probably enough. We've had enough time to read all the details about Charlie's impressive biography here. I'm not going to read it all out to you again. I would rather listen to him and hand over to Charlie to give us his presentation.
Okay, thank you very much. I will unhide the slide that I sometimes put in depending on the audience. So, which is a picture of me doing what we were talking about before on a little tractor.
We want to see it now. We want to see that now.
Yeah. Right. Let me share my screen and we'll get cracking. Right. Okay. Oh God, we've gone to the start of the slide pack, which is what I wanted.
Let's do it in reverse for a change.
Yeah, there we go. Right. So you can see one slide, I presume?
We can see one slide and we can see it very clearly.
Excellent.
Over to you.
Right. Then I shall begin. So thank you very much for inviting me to speak. It's great to sort of talk about the subject and a little bit about the institution and sort of my journey. I've only been in the role for about a year now. So I've been a member of IAgrE for many years, since I was a student back in the early 90s. And then I had the opportunity to join as the chief executive in October last year. So I took up the role. So basically a year in. So I'm still classed as the new boy. So yeah, great to be talking to everybody. So I'm just going to talk a little bit about what ag engineering is, because it's a very, very broad, diverse subject. Again, a bit more about IAgrE and what it does, my journey, why I'd recommend joining, a little bit about membership and registration, then we can have some questions at the end. So what is agricultural engineering? Well, it's not a very good description to start with of the range and sectors that are covered. So it's really the appliance of science, engineering and technology to land-based industries. And we tend to say land-based because in reality, you know, it's all of those ones at the bottom there. So it is very much centered around agriculture and land, but it's also encompasses forestry and horticulture and environmental and amenity. So it is not just ag. So it's not a great description to start with. The industry is, the profession is very old. Certainly in Europe, it tends to have been centered around farm machinery, producing equipment for food and that sort of stuff. So a lot of these companies are old companies that made, you know, farm equipment for towing by horses or working with the produce. So consequently, you know, certainly from my perspective, there's a lot of famous engineers that have gone on to make some pretty large companies in the world of ag. So, these are big global companies, and they all started predominantly with farm machinery. So you've got people like John Deere, Harry Ferguson, Daniel Massey, Henry Ford, Cyrus McCormick, Joe Bamford. We're all engineers who made significant amounts of farm machinery. So you could argue they are agricultural engineers. Engineers have made a huge impact on the mechanisation of food production across the world. I am a little bit biased, but if I look at some of the developments that have had significant impact, a key one for me is Harry Ferguson, his little grey Fergie, many years ago, absolutely mechanised agriculture and brought tractors to the masses. And then you've got other things like self-propelled equipment, such as the combine on the left there, really dramatically increased the productivity and the work rates in producing food for people. And then you've got the introduction of robotics, and believe it or not, we've had robotic milking in livestock now since the early 90s. And the interesting statistic now is that for new parlours that are being purchased, there are more robotic parlours now than the manual systems. So the robotic installations have taken over, which is great to see. And there's quite a few different companies producing that sort of equipment, and it's very well accepted. As I mentioned before, the title agricultural engineer is not a great description of the sectors covered. And I would say that, there are lots of people who are agricultural engineers, but they just don't know it. If you're working as an engineer in agriculture, you're doing agricultural engineering. The interests, there's a lot of focus on tractors and machinery, as you can imagine, but there's also interest in precision farming, and that doesn't necessarily have to be machinery, it can be livestock. There's a lot of activity in precision livestock farming now. Soil and water plays a huge theme. There's a lot of ag engineers work in that field because you've got irrigation and drainage, and obviously anything associated with land is a significant part of it. And that then links in with the environmental side. That's very strong these days. There's a lot of talk about sustainable farming and looking after the environment and climatic change, and all that gets drawn into agriculture. Animal production is a huge part as well, and of course you've got horticulture, food production, and forestry as well. So really, really broad, diverse range of subjects. There's a huge amount of sectors and a huge list of job roles. And I remember looking at some of our documentation, membership documentation, and I just took a screenshot really of that. You look at some of the different sectors there. You've got machinery design, you've got robotics and automation, you've got education and training, you've got agri-food supply chain. There's endless sectors, and also an endless amount of job roles as well, from product development through to consultancy and manufacturing and research and all sorts of different things. So huge subject area. 21st century ag engineering is pretty much the same. It's still understanding how the machinery and the technology integrates with the plants, the animals, and the land. And we often say that ag engineering is a convergence of disciplines. So you'll find that a lot of other disciplines work in engineering, in ag engineering, such as chemists and biologists and environmentalists. And also we talk about it being a convergence of disciplines. So you'll get people from other engineering disciplines involved. So civil engineering, for example, get involved with livestock buildings and the infrastructure. You've got mechanical, you've got electrical, you've got electronics, you've got chemical engineering, and all these things get drawn into what we call agricultural engineering. So, it quite simply isn't just about tractors and combines. It is truly multidisciplinary. You've got people in machinery design development, precision, soil and water, as I mentioned before, drainage, robotics in livestock, robotics in amenity now, with robotic lawnmowers and things like that. So a really, really diverse subject. I think it should make it interesting for everybody, because the amount of different areas you can work in, there's got to be something in there for anybody involved in science and technology. So who are the IAgrE? Well, we are a professional membership organisation, and we have grades for everybody involved in engineering, science and technology within ag, and also the environment and land-based industries. And I do stress all. We bring together students, technicians, academic scientists, practitioners and industry. So a whole group of different people to share knowledge and promote professionalism in advancing the application of technology in the land-based sector. We are a registered charity because we work towards for public benefits. Obviously, food production is a pretty important thing that we're involved with, and we are actually a professional engineering institution. So we're accredited by the Engineering Council and the Society of the Environment for professional registration, which I'll talk to you a few slides' time. So there's about 43 different professional engineering institutions. There's a snapshot there's the Institute of Mechanical Engineers, Institute of Chemical Engineers, Highway. So a whole host of different groups of people representing the different disciplines within engineering. But the important one, of course, is IAgrE. So what do we do? Well, we're a professional membership organisation, so we're a big club. So we provide a range of content and benefits for our members. So I'll talk about that in a few slides' time. Professional registration is a big part of what we do. So we do a professional register for engineers and environmentalists. As I say, we're governed by the Engineering Council and the Society of the Environment to do that. We very much promote the profession and careers in it. So where we can, we're always promoting agricultural engineering. There's a real shortage of people at all levels in our industry, whether it be technicians working on machinery in dealerships right through to college lecturers, whether it be FE or HE. So there's a real need for people to really get involved in land-based industry. And there's a lot of focus on it at the moment. There's a lot of focus around ag technology, sustainability and farming practices. So it's a great time to get involved in it. We also accredit and approve various courses. So we accredit various degrees at some of the universities, such as Cranfield, such as Harper Adams and Munster University, to name a few. We're also getting involved in accrediting some others. So we're sort of branching out a little bit into food engineering, where you've got food engineering that's got more of a bias towards the ag side, so nearer to the farm. There's certainly a keenness for accreditation. And we also do some industry training and accreditation as well. We participate in a lot of working groups, so we're a good voice for the profession. So we sit via the Royal Academy of Engineers on the National Engineering Policy Centre Partnership Group. So we have a direct voice through the NEPC and the Royal Academy into the government. So we do get the opportunity to work on various things. We also get involved in things like writing content, advising on content for syllabuses, for college training, that sort of stuff. So lots of working groups. We also partner with our colleagues in other engineering institutions where required to provide national policy, government policy support as well. We're very closely associated with academia and research and industry. So we sit in the middle of all that because we're very much about the people. So we get to see a lot of the stuff that's going on in industry and research and some of the universities. So it puts us in a great position to see what's going on. And we also offer industry prizes and awards. And we publish peer-reviewed papers in our Biosystems Engineering journal, which I'll talk to you about a little bit later on. Okay, so what I was going to do is just sort of go through my journey into engineering and some of the things I've done in my career prior to IAgrE. So I grew up, I'm very much from an ag background. I grew up in a mixed farm in Staffordshire. And I suppose what got me into the engineering and technology side was growing up on a farm. My granddad bought me a little tractor when I was very young, which is a little Ferguson tractor there, which some of you might recognise. There was millions of them made across the world. And that really got me into engineering, and I was fascinated really by, when we had a chap that came to do major repairs, and he got this agricultural engineer written down the side of his van. And I suppose back then that's what I thought an agricultural engineer was, even though it's obviously a much bigger subject than just that. I was always the first in the car to go to the local dealership to have a nose round and see what new equipment was available. So that really got me into it. And I wanted to be a tractor mechanic, really. That's what I wanted to do when I left school. And I suppose I've got my father to thank, really, that he basically said, well, do that, but do something a bit more theoretical. So I ended up doing a BTEC National Diploma back then, which was a 3-year course with a sandwich placement. And it was great for me because it was a 50-50 practical theory course. So it gave me the opportunity to satisfy this practical desire that I had, but also it got me into the theoretical side. And all of a sudden, the maths and the science and that sort of stuff started to make sense because it was being applied to something that I really liked and was really interested in, i.e. tractors and farm machinery. So I really got the bug back then. I did my placement at the local dealership, and then I went on to Harper Adams in Shropshire, started on the HND and then quickly moved on to the degree course, and got myself my BEng back in the early 90s. So, I definitely didn't want to do A-levels at school, but, you still get there by another route. And I really enjoyed that route into it. I then started my career working on chemical spraying equipment. So at the time, this is the sort of early 90s, salmonella was a big challenge still in animal feed. So there was a company I worked for basically specialised in chemical treatment of animal feed and getting rid of salmonella. So this company did a variety of things. They were a chemical company, and basically my role was sort of split 50-50% designing and installing chemical spraying equipment. So I would go out and do site surveys, design the installations, get all the stuff together, and then go out and visit the site and, with the help of some contractors, install the equipment. We did dockside installations. So you can imagine big cargo ships coming in with barges full of material from overseas, and that material would be unloaded from the boats into hoppers, and then that was then fed into lorries to deliver off to the feed mills. So we had equipment that would spray this chemical on and mix it in during that unloading process. We also had mobile processing plants that we took down warehouses. So you'd be faced with 100,000 tons of material in a warehouse, and you treat that material through this equipment. And then we did some specialist installations in feed mills to apply this chemical on as well. And it was good fun. Travelled all over Europe and the US, UK and Europe, went to the US for training. But really, my heart was in something with an engine and 4 wheels. So I wanted to get back to agricultural machinery. And at the time, I applied for some roles in JCB and ended up basically gaining a junior engineer's role in JCB. So over those sort of 5 years, I was a design engineer, then a senior design engineer, working on the telescopic handler product, which I'm sure many of you will have seen on building sites and farms around the country. So really, really popular product. So very much CAD-based, designing components on the computer. I suppose what made me nervous at the time, thinking I'd be sat in front of a computer all day, and that's very much not the case. Obviously, it's a CAD-based role, but you're out with suppliers, specifying parts. You're in the workshop with the technicians as they're putting prototypes together. And then you get to liaise with the test and development guys as they start and develop and use the product. Things go wrong, things need improving, things need fixing. So you naturally get involved in that as well. And then when a product gets to a certain maturity, there'll be key customers that we'll put machines with on early testing. So those customers will use those machines, and you'll get feedback. And then you'll look at working with the customers and the engineers then to try and improve it and resolve problems and that sort of stuff. And one of the good things about working at JCB as an engineer is that the example product there, the telehandler, JCB pretty much make everything. So they make the axles, they make the gearbox, they make the engine, they make the large structures, they make the hydraulic cylinders, they make the cab. So you can get involved in a variety of different areas and really become a specialist or lead projects. So after a few years, I then got promoted to a principal engineer, managing teams of engineers working on a project. So I would be responsible for project briefs and budgets, project plans and so on, and reporting status into the senior management. And then after a few years, I was then promoted to product manager, where I looked after multiple projects. So I'd have several projects under my responsibility, and it was my responsibility to look after the budgeting and the planning and the reporting of those projects. So I did that for about 9 years, and then I was invited to my boss's office and got told they were looking for a new chief engineer on land power. And with JCB, you don't turn opportunities down, so I duly accepted, even though I was really nervous and worried because it was quite a big step up in responsibility for me. So I became chief engineer for land power, which is the business that makes the high-speed farm tractors that JCB make, Fast Track. So I was responsible for all product design and development. Much larger team, over 40 professional engineers and then workshop technicians. And there wasn't an area of the machine that we didn't touch, so we were into engines, axles, gearboxes, all sorts of stuff. We also worked with some strategic partnerships with big companies such as AGCO, who supplied engines and gearboxes for us on the Fast Track. Because the product is a lot lower volume than the likes of the telehandler, JCB tend to know all the customers that buy new tractors, so you get a good relationship with some of the customers. And also, as I mentioned before, you put prototypes out with customers to allow them to test them and ensure they're fit for purpose before they go on sale. You also get to go to trade shows and conferences and supplier visits and all that stuff as part of the job. The interesting thing with the Fast Track is because of the way it's designed, with a chassis, you get a lot of special conversions that we tend to support. So you can see the one there on the right of a forward control self-propelled sprayer. And then the two at the bottom are German machines. So the Germans used to love modifying machines to suit their markets. So you can see machines there for salt spreading and snow ploughing, and also mowing verges on autobahns. So I did that for 11 years, and then I was invited into my boss's office again and asked to take up a role as chief engineer on backhoe loaders, which is the typical JCB that a lot of people know and recognise. So I did that for 4.5 years. That was another big step up in responsibility. And I'm responsible for global backhoe across the world, product design and development. Much larger team, 60 plus people in the UK, and then another team of 30 odd in India. So the Indian market is a huge market for JCB. The actual backhoe product is made in a number of factories. So there's a big factory in the UK on the way to Alton Towers, which a lot of people will know. There's also 2 huge factories in India, one in Brazil, one in Russia, and one in the USA, all making backhoe loaders. So they probably make about 250 backhoes a day around the world. And 150 of those are made in India and stay in India, which is absolutely bonkers when you see it. Really, really popular product. Lots of different versions, a little 1CX right up to the big sort of 4DX there. So it's a huge range, really, even though they all look very, very similar. And during my time there, a lot of the focus was on powertrain and cab because it's a very mature product. But you do get involved in conversions. Probably one of the biggest customers around the world used to buy them without the backhoe attachment on, and then they would fit what can only be described as an oversized chainsaw on the back, and they're used for slicing up marble in quarries. So they'll basically drive the machine to the quarry, sit it in front of a block of marble, set the saw going, and then disappear off and do something else while the machine chews its way through this huge lump of stone. So that's an interesting conversion to see. So I basically left JCB in the middle of 2020 and then took up the role with the IAgrE. So why join the IAgrE? Well, it's very much can be a constant in your professional life. But a lot of people do join as students, and those that stay tend to stay right through into retirement. So we have a lot of retired members as well. So a real interesting demographic in IAgrE, and a lot of experience, and they've seen a lot of changes over the years. Even if your job changes or your careers change, it can be a constant, and people stay in there. It's a great support function. So we provide a lot of career support for people. We've got it's an open membership, so we can put members in touch with other members if they want some advice on particular areas. And we have a jobs board as well, so that's often quite useful in our industry. Because of the diversity of the industry, we end up with a diverse group of members. So it's a great source of knowledge and experience for our sector. It doesn't matter what job you're doing, you can bet your life that somebody in our membership will also be doing a similar job. And sometimes it's great to be able to bounce things off other people not in the same company, with a bit of confidence. It's nice to talk things over with other people. So I think that's a valuable part of it. We're also a good source of material for continual professional development. So as you go through your professional careers, professional development is a key part of that. So we provide a lot of content and coordinate professional development for people. And as I mentioned before, it gives you access to like-minded people in the industry. There's always somebody there that's doing a similar job to yourself. Excuse me. Recognition of competence is also a big part of what we do. So professional registration, which I say I'll talk about in a few slides' time. So what I've got now is a short video, a few minutes. And I do like to play this. It doesn't matter what the audience is really. But it really just gives an overview of some of the technology that is already embedded in agriculture. So this is not new technology. This is technology that's with us today, which farmers are using. And it really gets people to think about, well, this is now, what's going to be in 5, 10, 50 years. So I do hope the sound works, but I'll hit the play and...
Agriculture is changing to meet the challenges of the 21st century. Agricultural equipment has a big impact in all areas: arable crops, livestock and specialised crops. The development of new technologies has revolutionised the operation, performance and use of machines. GPS guidance, accurate to just 1 centimetre, allows precision working on increasingly wider machines. It provides the driver with improved operating comfort, removing the need to twist around to watch the implement. Thanks to GPS, environmentally friendly techniques such as mechanical weed control using hose are returning. GPS allows field mapping, and the guidance system now knows when to stop output on sections of sprayers and fertiliser spreaders to avoid over or under chemical application. 3D modelling of the spreading pattern of farmyard manure using new test rigs, such as the one developed by Erstia, the French research organisation, has helped achieve today's very large working widths and efficient and accurate use of manure. The arrival of 100 horsepower plus high clearance tractors with full electrical power and transmission opens up very many new prospects. The operators' cabs on tractors and self-propelled machines offer everything you could want in terms of ergonomics, driving comfort and operational assistance. The development of ISOBus allows several implements to be connected to a single terminal for the operator to view the performance of each one. The arrival of tablet computers is further simplifying operations by allowing each driver to have their own customised control screen. Thanks to the internet, setting up implements is simplified. It is even possible to control machinery remotely from the farm or the dealer workshop, changing settings to optimize machine operation or to perform diagnostic or maintenance tasks. The arrival of drones offers new solutions and options to satellite imagery, including to map field plots, analyse nitrogen requirements, and to provide precise fertiliser, pesticide or irrigation application. In the livestock area, automation, including robots, brings more comfort to milking or feeding. The farmer can monitor the health of his herd more accurately and can provide a personalised diet for each animal. Robotic milking allows cows to control their milking times at their own pace. The cups are positioned smoothly on the teats thanks to a camera guided by a laser beam. Robotic feeders prepare a specific animal feed mix from a program determined by the farmer and then automatically distributes it in the selected stalls using automatic guidance. With techniques such as visual recognition and sensors measuring all external parameters, prototypes of robots, autonomous in their movements and actions, have already been established in research labs. Agricultural equipment has a significant impact on the quality of products that agriculture produces for the agri-food sector. Consumers also benefit from better protection of the environment and constantly improving traceability of products. To implement all the progress that lies ahead in the coming years, the agricultural equipment industry offers motivated and dynamic young people exciting jobs in research, testing, sales, after-sales, training and consulting.
Okay, so I hope the sound played all right. So, I mean, that video was produced for the European Society of Ag Engineers, and it's probably, I think it's about 3 or 4 years old now. So, you know, and things have moved on in the last 3 or 4 years. So, you know, you think about 5, 10, 20 years time, you know, what we're going to have, you know, what skills and knowledge will we need in the future, you know, whether you're a technician working in a tractor, machinery dealership, you know, how many of today's skills are going to be redundant. So we're already seeing electric drive machines, hydrogen engines starting to come in. So the traditional diesel engines are going to slowly disappear. And also, you know, how do you keep yourself up to date in a fast moving world? And I think, you know, that's where, you know, membership of the likes of IAgrE is a great way of doing that, because of the content that we put on and some of the areas we get involved with. So in terms of membership, what do you get? Well, we have a quarterly members journal, and we have electronic newsletters. Around the country, we have local branches, technical groups that have a variety of different meetings and visits to various organisations. We run quite regular lectures and podcasts now. So each month we'll run a lecture, what we call a lunchtime lecture, which are really well attended these days. People can just log on in their lunchtime at their computer or on their phone or tablet and listen to something. Great source of CPD. We run an annual conference, and we also put on specialist workshop and events throughout the year. And we can provide career guidance and job opportunities for people because of, you know, we were involved with academia and industry. We can see some of the things that are going on. I've mentioned before this opportunity to network with industry professionals. That's a great plus with professional membership of IAgrE. And I also mentioned before about the National Engineering Policy Centre and some of the working groups. You know, being a member gives you the opportunity to get involved and participate in some of this stuff, in some of this national policy and things that are going on. So there's one that's going on about at the moment, which is Code of Practice for Autonomous Vehicles, which is a really interesting one to be involved with. Mentoring through the registration process. We can provide mentors and we guide and support people through that process. We have a great system, online recording for CPD. We also have a phone app which allows you to log your CPD and then you can update it at a later date on your computer. we get various discounts from various organisations such as Halfords and Prof magazine and so on. And also membership of IAgrE also gives you membership of the European Society of Agricultural Engineers, which I think now post-Brexit, it gives us a link still with Europe for this particular discipline. So I mentioned Landwards. So this is our professional journal, a couple of thousand subscribers. It's available electronically or hard copy. We welcome articles from anybody, to be honest. We love articles from all types, whether it be a student project or some high-end research in autonomous vehicles. It's a real diverse read, and it's a quarterly publication. We also have a journal called Biosystems Engineering, which is a learned journal. So this is the official scientific journal of the IAgrE and the European AgEng group, and it's owned by IAgrE. So it's a monthly journal, about 20 papers per journal, and it's very high quality research in agricultural and biosystems engineering. So we get about 1,200 papers per year received, and we publish about 18% of them. So it is a high-end research. Most universities and academic establishments are probably going to have a subscription to it anyway, but we do offer some excellent discounts for IAgrE members. So normally this journal is a couple of $1,000 for a subscription. So you can get that for, I think, about 60 odd quid if you're a member of IAgrE. And it's held in high regard. Its impact factor and citation, which is how you measure the performance of these journals, is really high and is gradually increasing as well. We've got a great editorial team that's really international, part of that. So professional registration, I've mentioned a couple of times. So this is a big part of what IAgrE does. So whilst you're at college and university, you are gaining academic qualifications. Then, of course, you go out into the workplace and you can gain professional qualifications. So in our sector, we have Eng Tech, IEng, and CEng for the engineering side, and then we have environmentalists. We have a registered environmental practitioner and chartered environmentalist for the environmental bias side. And they're awarded from the Engineering Council and Society for Environment. So we're a licensed body to award those. So professionalism, I mentioned the words professional and professionalism a few times today, but it's good to sort of reflect what those words actually mean. A profession, a professional follows a profession such as law, medicine, or engineering. It requires considerable training and dedicated study. And then as a professional, you will be required to demonstrate professionalism, which needs character, spirit, strong ethics, a desire to act to the best of your abilities. And as a professional person, you'll offer advice and guidance, leadership, and wise counsel. And you'll gain respect, but you must still work hard to maintain it. And when you're in education, that's the start of the journey. And a professional body such as IAgrE, and eventually professional registration will enhance that respect and standing. So benefits of professional registration, very much improved career prospects and employability. I think because you're focused on your career and your professional development, you're more likely to go on to bigger and better things. So it very much does improve your career prospects and employability. And because of that, you've got a higher earning potential and better progression opportunities. And what professional registration does do, it demonstrates that you've got a professional attitude. And I think these days that is really valued by employers, and of course customers as well these days. I think, it gives you enhanced status, it makes you feel better. Some letters after your name, gives you a bit of higher self-esteem. And it's very much an international recognition of competence and commitment. And it's done independently by assessors. So we have a number of assessors that will assess. So it's very much third party, done by reputable peers. And we hope then that, being professionally registered gives you a greater influence with your own organisation and industry. And I think these days, top employers do expect it. So I mentioned about earning potential. Well, the research, although this is a couple of years old, 3 years old now, it does indicate that professionally registered people will earn more money because they're focused on their career and their career development. So the chances are they're going to go on to better things. So that's a sort of snapshot of salaries across the industry. So what next? Well, for those people studying agricultural engineering and associated industries, we offer free membership. So the membership is actually funded by the Douglas Bomford Trust. The Douglas Bomford Trust was set up from the family of the machinery pioneer Douglas Bomford when he passed away in the late 60s. And it's a registered charity, and it was set up for the purpose of advancing education and training and research in the science and practice of agricultural engineering and associated disciplines. So they provide sponsorship as well. So they'll provide scholarships to students and awards and things like that. So they really support it. And we work very closely with the Douglas Bomford Trust. Our membership is very cheap. It starts at £38 direct debit for technicians. And then for those with degrees, we tend to start at £44 for an associate membership. Dead easy online application process. Sign up, take advantage of the benefits on offer. So, a lot of the online material that we're doing these days is really, really good. And then we really urge people to start preparing for professional registration. We've got some nice and straightforward, simple processes and some great people who know what they're doing on that. We can sign you up for a mentor if you don't have anybody in your organisation that can do that and really support your career development. A lot of what we do is via email, so obviously keeping contact details up to date is really important. And that is about it. So we can have some questions. Now, I did mention we were having a discussion about ploughing at the start, so I'll pop this slide back in, which is my obsession as a 10-year-old, still with me today. So that's my 1961 tractor at a local match, doing a bit of therapeutic ploughing. So people with OCD probably quite like it because it's got lots of straight lines and things. So nice bit of stress relief for me. Okay, thank you. That is it. So I think we're banged on 40 minutes, aren't we?
Perfect. Thank you very much, Charlie.
I hope that was interesting.
I hope it, for me it was. I hope it was also for the others. So thank you very, very much. Sorry. Right. My daughter is having problems with the telly. There we go. Just turn it off. Right. Thank you very much. And indeed, we also have Douglas Bomford Trust among our sponsors for CDT projects. So there's another link there. We're going to move on to a quick panel discussion, and let me introduce the panel briefly here. So we've got young, ambitious engineers. Rachel is having a chuckle. Oh, Greg, of course, if you think that I've been referring to him. So let's have a quick round of Rachel. If you want to unmute your mic and say hello.
Hi.
So Rachel is from our newest intake of CDT students, has just started her MSc phase. Then we've got another young fellow here, Stephen. Want to say hi?
Hello.
Stephen is also part of our MSc program for robotics and autonomous systems. And then we've got another young fellow there. Greg Cherniak, who's an associate professor in agri-robotics here at the University of Lincoln. I'm going to give over to you guys. So who wants to have the first question on what Charlie has just talked us through? Who wants to?
I've got 3 beefy questions, so I don't mind waiting until after Rachel.
Oh, you start with one, I would say then.
Okay.
You pick your best.
Oh, my best one. Okay, so okay, let's go with this one. So as someone who grew up with tractors, this is directed at Charlie as well, sorry. As someone who grew up with tractors, do you welcome the use of autonomous drones and vehicles and stuff in terms of aiding agricultural engineering? you know, whether it be just by pest control or spreading seeds in terms of the drones, but also in terms of like, you know, the tractors as well, maybe having autonomous tractors? Or do you think humans should remain in the driver's seat? Because in the video you showed, a lot of the times, although there was mention of all these fascinating technologies and stuff, I could still see that there were human beings either driving the tractors or the vehicles, or like in the work somehow. They were always embedded. Do you think this should change though? Because this would mean, in my opinion, that people wouldn't be needed on site as much, and it would also mean that children in the future wouldn't get as much exposure as you had, because they wouldn't be able to go on site, for instance. And it would mean that the future generations wouldn't have the same experience that you did growing up, and, you know, being so close to the tractors and just being kind of getting your motivation for your essentially where you are right now through actually being there, being a part of it from a young age. What do you think?
That was all three questions, Steve, wasn't it?
No. That's still the one. Do you think humans should stay apart, or what's your opinion?
You've picked up on some really, really good stuff there, and I'm probably going to forget now what you've asked as I talk through it. I suppose one thing I get a little bit frustrated with is people thinking robots are not tractors. So if you understand what a tractor is a prime mover that is useless on its own, and it only comes into its own when it has things attached to it. So a tractor is pointless on its own. So unless you put an implement on the tractor, it then performs a function. A robotic tractor is the same, that a robot on its own is useless, but until you start attaching things to that robot to make it do a job task, there is no difference between a robot and a tractor. And also, if you look at a tractor that's an autonomous tractor with no driver, it's a robot, isn't it? So there's a funny description there. I think people get carried away with autonomous things and robotics and things like that. It's a work tool that does a task. How it's powered, how it's controlled is almost secondary, isn't it? So I think sometimes we can confuse things a little bit. You also picked up on about humans and their involvement. I suppose there's a big perception thing, isn't there, still, with machines that can work on their own. I'm sort of very aware of the work that's done in Lincoln on the strawberries, for example, with the autonomous machines there, picking strawberries, looking after strawberries. And I suppose the more we see, the more it will become accepted. Certainly with big agricultural machines, they've got massively automated over the years, which has reduced the amount of people involved with the tasks. And I suppose that will continue. There's a lot of nervousness, I think, that you pick up from the industry about doing away with drivers and, you know, is that going to be possible? But if you look at a real modern high-tech tractor now, the driver, once everything's set up, the driver is literally sat there making sure everything's working okay, because it's steering itself, all the functions are automated, and the guy is just there, or the girl is just there to make sure the thing is working correctly. And we'll even do headland turns on its own now at the end of the row. You know, the sequence is all automated. So it's getting so automated. And I suppose the difficult bit, where you've got really complicated tasks, are we always going to need a person in there supervising? I don't know, because you might be able to let the machine work on its own and you supervise, sit at your computer in your farm office. And there's some of that already happening with some of the robots. AgroIntelli is an example that I went to have a look at, which is a gantry tractor style robot, which is very much driverless. You know, you set it up, you put it in the field, you set it going, and then you go off and it alerts you if there's a problem. So it is happening. You know, then if you look at the livestock industry where you've got robotic milking, the robot is milking the cow on its own. There's no human intervention. The cows walk in, the robot milks, the cows walk out. The guy or girl looking after the herd is busy looking after their herd, you know, making sure the health is there, making sure the systems are working and that sort of stuff. So it's slowly coming. I suppose farmers are, they're not, I suppose they are conservative, but then they are adopters of technology. And I do hate sometimes the way some people say that, digitization of agriculture seems to be really lagging behind everything else. Whereas you look at the technology in agriculture, it's immense. It's really sophisticated stuff. And I think some outside industries come in and just think they can digitize agriculture, which I don't know what that actually means. But it's an incredibly complex system, farming, whether it's the equipment, whether it's what you're doing, the weather, everything else that's all associated with it. So they're not. I think they're conservative on the technology. That's probably not the right way to describe it. They're conservative until they see something work in practice, I guess. But they like adopting technology. There's no question. You can see that. But have I answered some? No, there was one other thing you picked up on that was really important, and that was young people's association with equipment. Yeah. I'm really concerned about that, because that is a lot of people in our industry that got into engineering got into it because of how they were brought up. And I think if you start and take that away, is that going to affect the people that come into engineering? I don't know. It's a real tricky one, because you sort of grow up around the equipment. And I worked quite closely with some Indian groups in JCB, and they're very, very different. In the UK, most engineers messed around with things as a hobby, whether it be cars, bikes, tractors, whatever. In India, you don't get that at all. India, its engineering is very white collar, and it's office based, and that's an engineer, and it's a high profession. You don't get that association so much in India, and it'd be a shame if we lose that, really. So I think that's really important. But, have I answered all your questions?
Yeah.
Not all of them, but we need somebody else to ask a question as well. I think Greg has his hand up.
Yeah.
I should really let Rachel to ask the next question, but I'll be impolite, because I think I'll be rude, and I'll ask the question, because I think it's a follow-up to the questions asked previously. I'm interested with these external pressures that come from the fact that, is there enough tractor operators and these heavy machinery operators in the market? What's the tendency? Are people still interested in these jobs, and how does the outlook look like when it comes to drivers?
I think there is a shortage of people. I have a lot of friends who are farmers and contractors, and they do struggle to get staff. So there is. I worked a few years back, spoke with some people in Japan, and they really struggled with their younger generation. And their average age of farmers in Japan is really old, and they can't get the young generation interested in the practical aspects. The young people want to be involved in agriculture, but they want to be able to do it from a desk. So they were looking at autonomous tractors simply because they couldn't get people to want to work on them and drive them. I think, there is skill shortages in operators. I think you can look at what's happening with truck drivers at the moment. You can't get people to do it, but and then you look at driving a tractor. Well, it's a complex piece of equipment, long hours, not great pay. So it's a challenge, isn't it? So, there's almost a desire for more automation, more autonomous vehicles, because there isn't the people there to drive them. So, and that's certainly with the soft fruit industry, that's a clear one, isn't it? That availability of labour to pick fruit, post-Brexit, post-COVID, has really hampered that, hasn't it?
Thank you.
Rachel, come on, we want to give you a chance as well.
So first off, thanks for the interesting stories. I guess my question was kind of based on that. It's like, what's the most and perhaps the least successful introduction of a new product or technology into agriculture that you've seen in your experience?
I think as working for a commercial organisation, you get involved in lots and lots of projects that never see the light of day. I think there's projects. The most enjoyable projects were the agricultural projects, quite simply because working with the ag industry, there's a group of passionate people who really are interested in what they're doing. The construction industry is quite cutthroat, very accountancy based, whereas the ag industry is a much nicer industry, enjoyable. But yeah, you get involved in all sorts of projects that don't see the light of day, or some that get very far down the road and then get canned, so you feel like you've wasted a lot of time. But I suppose for every, and that'll be the same in a lot of organisations. They'll work on things, get so far, and then decide, look, this is not the right thing to do here. Let's just chuck it in the bin and forget it and move on. And I've worked on a few projects over the years where that's happened, and it's really frustrating, but it's probably been done for the right reason. And some of the more successful projects, I think you know they're going to be successful before you really get going. You just think this is, when you start and look at the conceptual stuff, you think this is really good, this is going to really work. And that enthusiasm just keeps going then, and it gets better and better. And then you get the thing launched and it's successful and it's great fun, So yeah, there's ups and downs. And I think there's the different parts of the process, from the conceptual stuff early on right through to making something over and over again on a production line to a high quality standard is, the conceptual stuff is really, really enjoyable. The putting it into production is really hard. And that is the most hardest part of any project is, right, we're going to make 20 of these a day now. And then you think you've got problems before, my God, making 20 every day, day in, day out, suddenly things get very clear in your mind, because if something goes wrong, it's going wrong 20 times a day. And before you know it, you've got a yard full. So different parts of the process. And I suppose that's something that, because of my practical background and commercial background, when I see people talking about new machines, new robotic machines, I kind of think, my God, when you start making these, if these go into production, serial production, you start making hundreds and hundreds of them and start dishing them out around the countryside. You're not selling a piece of equipment with a robot, you're selling a system. So at the moment you sell a tractor and the dealer looks after that tractor and the farmer uses it and away it goes. I think we've seen that with robotic milking. You don't buy a robotic parlour, you buy into robotic milking, and it's a system and it's a way of life, isn't it? Then I kind of think autonomous vehicles are going to be a bit like that, aren't they? You're going to buy a system, a farming system, and somebody's going to have to support that day in, day out, because it doesn't matter whether it's Monday morning or Sunday night. If something breaks, somebody's got to be there fixing it to get it going again. So yeah.
That links so nice to a question that we had from the audience that I have to kind of ask that as well. The keyword was repairability. So it's the maintenance question really, and to what extent that, there's all this innovation at the moment, whether proprietary technology and closed source could actually get in the way. In your video, there were talks about ISO-BUS, that is a sort of standardized interface now on these agricultural machines. And what we see right now, there's a lot of innovation. We see lots of startups basically doing their own thing, and what the impact of that may be on exactly what you said, the scalability, that you have an actual system that goes out in thousands, like in high numbers in the field. And is it actually viable that all these companies do their own thing? Can they offer the actual maintenance for it eventually? So where do we need to go?
Knowing a lot of farmers, ISO-BUS has been around a long time, and my God, it's still complex now. And I think what will drive farmers mad is technology that doesn't work very well, and they get really frustrated now by different software systems, and why doesn't this work with that, and when I use this I can't do that, and they just get driven mad because the job they've got to do, they're not software engineers, they just need to get on and do the task in hand, and they want the technology to work. And it's a bit like, if you sat at your computer wanting to do something on your computer and the technology's not working, they're taking you away from your day job and you can't get on with your task. And I think that's the important thing really, that if you've got lots and lots of companies, how is it all going to link together? Because I think where the big companies will excel is they're covering all the bases. So all their equipment is talking on the same software level. It's all interchangeable. They've got farm management systems that can talk to the tractors, and it's all interlinked and makes it quite easy for the farmer. I think that's a concern really going forwards, and we've seen that with ISO-BUS, in that ISO bus is supposed to be a standard that, if you describe it to somebody who doesn't understand it, it's connectivity for tractors and implements, basically. So you've got your tractor, and it doesn't matter what implement you put on, you plug it in the back, the tractor recognizes the implement and it comes up on the screen as, this particular piece of equipment, and you can set it all up and away you go. When it doesn't work, it's painful. And I think at the moment, it's still a challenge in the industry. Yeah.
Excellent. Any last questions from the panel? Any sort of has something really pressing? I knew Stephen's got something, so a short one, Stephen. I'll tell you,
Okay.
A short one.
Okay. All right. So in that case, on the subject of the future, then, what comes next? Have you thought about what comes after mechanization and the introduction of robotics? What do you think the next focus will shift towards? That should be like a quick one.
All I hear is sustainability and climate. And I suppose a lot of people blame agriculture for climatic change. And I suppose what agriculture has done is basically ensure the world is fed. And I suppose agriculture has just reacted to this ever-growing population. And I suppose that the population is continuing to grow and will grow to whatever 9 billion. And then people are saying it will then start and tail off. But ultimately, you've got a growing population, you've got a declining land area to be farmed. So we've got to produce the food, haven't we? So there's all sorts of things going on, like vertical farming and things like that. So there's some really interesting developments. I think one of the things I'm really interested in personally is what's happening with machine emissions and the move to more renewable energy, sustainable fuels, things like hydrogen, that sort of stuff. So using green hydrogen to power equipment. And also the interesting thing, which we're running our conference on next month, which is future fuels. And it's not just about future fuels for machinery, but also, the beauty of agriculture is that it can actually be used as a carbon sink. So we can capture carbon through agriculture. So yes, it can produce it, but we can capture it as well. So there's lots of farming practices going on at the moment, studying, what can we do to keep carbon in the soil? There's some research going on about capturing methane emissions from some of the waste processes, which are incredibly interesting. So slurry from cattle, capturing the methane that's coming off that and then using that methane to power equipment. And there's a company, New Holland, who are just about to launch a methane-powered tractor. So that, it's a real first for the industry. So there'll be a gas-powered tractor that can run on methane, and you produce the methane from your waste from your farm. So real sustainable stuff. So I suppose looking forward, it's all going to be about how do we have sustainable food production to feed the world, and how agriculture is going to adapt to do that. I think this next decade is really, really exciting for people to be involved in the industry. Never before, because you think of what's going on now, and you think what's going to be, all the stuff we're talking about now, what's it going to be like in 10, 15 years? It's incredible.
Thank you very much, Charlie, and thank you to the panel. We are already 10 minutes over, so we really need to wrap up here. Thanks a lot. I think there was a lot to go, and I've pasted the chat for people to sign up to IAgrE as well in the link I've posted in the chat here. And I think there is quite an interest, I hope, that you've sparked among our students. Thanks again. It was a pleasure to have you here. Sorry, particularly to Stephen. I know you've had a long list of questions. Well, some of them I think are very good also to post to our coming talks, to our coming presenters, because they all these future questions are generally very, very interesting, and see what people that actually have the background knowledge there, how they will answer that. Charlie, was great to have you. We'll have the next CDT seminar on the 19th of November, same time, same place. Thanks everybody, and have a great weekend.
Okay, thank you. Please check out the website, have a look if you're interested in membership.
Indeed. The links are all there, so make sure you click those links before you close Zoom.
Okay, thank you.
Thank you.
everybody.
Bye.
Bye-bye.
Bye.